Hello, so I'm Ray Kim, and today I'm gonna talk about a new tool, new method that's really helpful in this vector world. So one was dot product that we used, and the other one is called cross product, and the sign is just X. Now, so this question is from chapter 13.4, number 24. So this is it's like basic application of cross product. So if we see here, it says find the equation for the plane that goes through the origin and perpendicular to these planes. So here we got two really important information. One is that it goes through the origin, so it gave us a certain point that plane should go through. So the origin equals that, right? So that is x naught, y naught, z naught. That's used for the equation of the plane, and it says perpendicular to these two planes. So one of the reason why we use cross product is by using cross product of two vectors is that we get a third vector that is both perpendicular to the two vectors that were used in the cross product. So now we should get a vector from these two planes and do cross product. So in that way we get a new vector, the third vector that is both perpendicular to a plane, the planes that includes the two vectors that were used. So that will fulfill this requirement. So if we mark this first plane and second plane, 1 and 2, from 1 we can derive a vector like this, which is a normal vector for number 1 plane, and from number 2 plane, we can derive, just taking out the coefficient, we can get the normal vector for the second plane. Now we got the normal vector from each, so we can also get a vector by using dot product. So a vector that becomes 0 doing dot product for each means that this vector is parallel to the plane. So by using dot product, we have to be able to get 0. So in the case of number 1 plane, so these vectors from number 1 plane and number 2 plane, that becomes 0 by doing dot product with the normal vector from number 1 plane and number 2 plane, means that they are parallel to the each corresponding plane. So now we got two vectors that will be used for our cross product. So cross product, the basic form of cross product is the same as matrix, and the top row is I, J, and K. And here goes the coefficients of the vectors. So number 1 vector is 2, 1, and negative 1, 2, 1, negative 1. And the second one is 2, negative 2, 1. So 2, negative 2, 1. So it's just same as getting matrix. So first part is ignoring the I row. It's 1 minus 1 times negative 2, which is 2, times I. And here we have to be careful with the signs. It's minus, then ignore j row, it's 2 times 1, which is 2, minus negative 1 times 2, which is negative 2, times j. Now it's plus, ignoring k row, it will be 2 times negative 2, which is negative 4, minus 2 times 1 is 2, k. So this cleans up to negative I. 2 plus 2 is negative 4, because there's minus here. And then it's minus 6k. So now we got a third vector by using cross product of the two vectors from the two planes that we're given. So this is a normal vector, another normal vector for the plane we want to get. So we can rewrite this as ABC form, which is negative 1, negative 4, and negative 6. And then it's easy, because we learned before, the basic form of the equation is a x minus x naught, and goes on like this. So because we got the equation, the basic equation of the plane, and we got the normal vector right here, and in the question we're given one point that we can plug in. So this cleans up very nicely. It will be negative 1, a is negative 1, times x minus x naught, which is 0. And then b is minus 4, and y minus y naught, which is 0. And then c is negative 6, z minus z naught, which is 0. And this becomes negative x minus 4y minus 6 equals 0. And this is a equation of a plane that goes through the plane, through the origin, and also perpendicular to these given planes. So basically I use cross product of the two vectors from the given planes, so I can get a normal vector for a plane that we want to get. Thank you.